In the last video, we learned how two equations given in their slope-intercept form can be solved together to produce no solutions, one solution, or infinitely many solutions. In this video, I will show you how to solve two equations given in their standard form using elimination, and I will use two examples to illustrate this today on MathBase. In this first example, we can see the two equations have been set up very similar to how you would try to solve simultaneous equations. These are given in the standard form. In order to use elimination, we need to match one of the terms from both equations. It looks like the y term will be the easiest to match here, so all we need to do is take equation number 1 and multiply everything by k. Line that up with the second equation underneath it, and minus that off. We will end up with an equation that attempts to find x. So here we have written x in terms of k as k squared minus 3k over k squared minus 9. If you guys are familiar with factoring, you will realize that this can be factorized. So x will equal to k times k minus 3 divided by k minus 3 times k plus 3. And we can stop right here to determine the k value, which is going to give you a certain number of solutions. We don't even need to go and find the y value. Notice how k minus 3 is a factor in the numerator and the denominator. This indicates the potential for infinite solutions. So when k equals to 3, we will get infinite solutions. Or in other words, the lines are coincident. As for k plus 3, that's not going to cancel with anything, and so we have to say that k is not allowed to be negative 3 if we want to get an x value. Or in other words, if k is negative 3, we won't get any solutions, which would create two lines parallel to each other. And as long as k is not equal to 3 or negative 3, we will get two lines that cross each other, which means you will have one solution. And just so you guys know, this question is the same as the first example I used in the previous video, so feel free to compare the answers to see what's different and what's not. In some ways, this is actually a much easier method to do, especially because elimination will be very familiar to a lot of you guys. Alright, so let's have a look at the next example, which is a little bit more complicated. So here we have kx plus 2y equals to 8, and 4x plus k minus 2, in brackets times y, equals to 2k. This will be a little bit more challenging to try and match together. And it looks like the easiest term to do that with is the x term. So take equation number 1 and times 4, and take equation number 2 and times k. Subtract them off, and we will be left with the y term equal to the constant 32 minus 2k squared. Once we rearrange that, we will see that there is a possibility for factoring the y value as well. And so we end up with y equals to 2 times 2 factors, 4 minus k, times 4 plus k, and that divides by two other factors, negative k minus 4 and k plus 2. When we multiply the negative back in, we will end up with a 4 minus k underneath. So once again, 4 minus k is a matching factor in the numerator and in the denominator. Since they can be cancelled, this indicates that when k is 4, we will get the infinite solution case because the lines are coincident. And if you solve k plus 2, the k value will equal to negative 2, which will indicate no solutions because the lines are parallel to each other. And this is apparent in the y value because when k is negative 2, you'll be dividing by 0, and so you won't get a y value, which means the y value is undefined. And when k is equal to anything else except negative 2 or 4, we will get one solution because the lines will cross each other. So as you can see, in this method, there's usually some factoring involved, but you don't have to do much comparison work. You just need to look for certain patterns like matching factors or a single factor that you're dividing on its own, and these would indicate the coincident and parallel cases. And then everything else would just be crossing for one solution. However, this method is only easy to do if the equations are simple enough to work with, and if they don't have the special case of where the lines cross at the y-intercept. Otherwise, you'd be involved with working with a cubic problem. So if you end up in one of those situations, the method that I taught in the previous video will be much more helpful. So if you guys enjoyed this video, please hit the like button. Let me know what you think down in the comments below on which method you prefer to use, or if you know a better way. And don't forget to subscribe to the channel by clicking the subscribe button down below and ring the bell so that you can get notified for future videos. Thanks so much for watching, guys. Have a good one, and I'll see you next time.